Saxon's Trig, lesson 118, is roots of polynomial equations. So we're looking for the answers to polynomial equations. And we've sort of been doing that in the last couple of lessons with our synthetic division. They use a term in here, depressed polynomial. I didn't find it to be of importance. I've never seen it somewhere else or on a standardized test, so I don't feel that you need to fully understand that. So then let's jump to example 1. Find the roots, find the answers for 2x cubed plus 3x squared minus 7x minus 3 equals 0. So if we quickly did our testing of numerator and lead coefficient 1 and 3, 1 and 2. So then I know that my answers are combinations of these to test. So if I start my synthetic division with testing whatever of those, let me go ahead and write my coefficients. 2x cubed, x squared, no x, I'm sorry, 1x, no x, there we go. And then I know I'm going to drop my 2. All right, so then which out of this combination do I want to test? And I know I've got positives and negatives for each of these. I need to find one that gives me an answer of 0. Now, if I were graphing it, everything that I chose to test would help me in graphing a dot that would be helpful for the graph. However, I'm looking for absolutely finding a 0 here, and it's just kind of Russian roulette. You have to keep picking until you find it. To avoid all kinds of synthetic divisions that don't work, I'm going to use the answer key in your example where it says that 1 over 2 in its positive will give me the 0 I'm looking for. But I would have already had to have tested 1 and 1/2 and 3, or the 3/2. I could have tested any of those. All right, and I wouldn't have gotten zeros. So 1/2 times 2 is 1, 3 plus 1 is 4, 4 times 1/2 is 2, -7 plus 2 is -5. Just a second. Oh, good grief, I've pulled the wrong one. Let me try that again. That didn't say 1/2, that said 3/2. Oh, try again. Okay, drop my 2. Oh, yeah. This is 3. So 2 times 3/2 is just 3. 3 plus 3 is 6. 6 times 3/2. 2 goes into the 6 3 times. 3 times 3 is 9. 9 and -7 is 2. Yes. And then I lose again the 2 and I get the 3. -3 plus 3 is 0. That's what I was looking for. So once I have the answer at 0, I know that 3/2 is one of the answers. Now, I don't want to confuse. You saw me do before where I took these and I turned them into an equation. So I'm going to go ahead and do that. So 2 is the coefficient to x squared, one drop below, plus 6x plus 2 equals the 0. And then I attempted to factor. And if I couldn't factor, I said, oh, well, I'm going to go back to my synthetic divisions. However, since this wants me to find all of the roots in this answer, I'm going to have to keep going. And in essence, here is what you're doing when I'm doing this. This answer goes back to being put in a parenthesis. And what you're saying is you have this with this equals the 0. So then when you're solving, you know that one of your answer sets is this positive 3/2, and then you're working on the answer set for over here. Now, I can quadratic formula if I can't factor, and I was mentally trying to see, because this would be 2x and x, and this would be 2 and 1. If I put the 2 here, I create 4 and 1. That's the highest it can get me is 5, so it's not going to get me to 6. I can't factor to get there, but I can always quadratic. So a is 2, b is 6, c is 2 from the x squared, the x, and the no x. So now quadratic formula, -b, -6, plus or minus the square root of b squared, 6 squared is 36, minus 4 times a times c all over 2 times a. And simplify. Negative 6 plus or minus the square root of 36 minus 16 all over 4. Negative 6 plus or minus square root of 36 minus 16 is 20 all over 4. 20 can split into whatever you see, 2 and 10, 2 and 5. So a set of 2's. So negative 6 plus or minus the 2 pulled out. The 5 was stuck in the radical all over the 4. And 6 and 2 and 4 will all reduce by 2. So negative 3 plus and minus root 5 over 2. These are two other answers for this problem. So this parts gave these answers. And I would write them in its positive and negative because that's two separate answers. They wrote them separated. So I would actually write that as negative 3 plus and minus root 5 all over 2 and say there are the three roots that I can have. There was something at the beginning of this lesson which I didn't state, which says that whatever the highest exponent value is, so for this problem that was the x cubed, I can have 3 answers, and that's how I know I'm looking for 3. So if it had that exponent of x to the 14th as the highest, you're looking for 14 answers in your list. And that is helpful to know that you have gotten down to where how many answers you're supposed to get. Okay, that was example 1. Let's look at example 2. Find the roots for x cubed plus 2x squared plus 6x plus 5 equals 0. So again, if I find my 5 factors and my 1 factors, I'm going to have 5 and 1 over 1. So basically, positive and negative 5 and positive and negative 1 are the only things I have to choose from. So I would do synthetic division. Coefficients are 1, 2, 3, 2, 1, none. Okay, that's correct, dropping my 1. Now, what do I want to test? And again, I'm looking for a 0, and I'm using the book to help tell me negative 1 because I don't want to do synthetic division. I don't need to do, but technically you would as you were trying these. So negative 1 times 1 is negative 1, adds to 1, multiplies negative 1, adds to 5, multiplies to negative 5, answer is 0. So again, what I have, if I'm writing it out long way, it's the x plus 1, because I'm putting it back into a parenthesis, and then I've got this equation, 1, which I don't need, x, 1 below squared, plus plain x plus 5 equals the 0. And then I'm trying to factor this. So mentally, I know that can only split into 5 and 1, and there's no way to get that, so I'm going to have to do the quadratic formula again to get. So this answer I know is negative 1. Oh, and how many answers should I get? 3. Okay, so here's one of them. This with quadratic formula will provide the other 2. So we have, I'll just list it. A is 1, B is 1, C is 5. So negative 1 plus or minus the square root of 1 squared is 1 minus 4 times 1 times 5 all over 2. 2 times 1 is 2. So negative 1 plus or minus the square root of 1 minus 20 over 2. So negative 1 plus and minus the square root of negative 19 over 2. Now that negative makes an I inside that square root. So negative 1 plus or minus I. And then the square root of 19 is stuck without my even trying it because I know 19 is prime all over 2. So here are my other 2 answers. And again, I still write it with the simplified doubled up format. They're writing it separate and saying negative 1 plus I 19 over 2 and then negative 1 minus I radical 19 over 2. They're writing it separate. I'm using the shortcut.